Hello. Hello. I do this every time. I can hear myself. One moment, please. Hello. How is everyone today on this third stream? That's much better. I can't hear myself now. Much better. Hello. So I have been working on... still can hear myself. I have been working on a DirectX 12 renderer so that we can put it into this engine, and I am quite excited. I know YouTubers always say that, but I'm quite excited because I've been building just a straight renderer, and I'm quite excited to actually be able to fit it into this engine structure that we're building. And this is also going to be the first time that that we were really going to get into the meat of DirectX 12. I know that a lot of people have been asking for it. So let's get on with it. As I say, what I've done is I've built a not a complete renderer, but a initializations for DirectX 12, and I have built a UI handler to go on top of that, so that we can immediately start working on things like scenes and what is going in the scenes, objects, etc., etc. So in the last episode, we left off that we were building our engine, our editor. And in that episode, we left it so it was mainly working, but I did have a few things that were just a few random errors on the end that we were having. So, for example, I think what was happening was when I closed this, we were getting errors. I managed to fix this rather easily. I realized that the build output path was not set correctly, so I've actually set that to just build directly into the Echoes editor build path, and that will allow us to just draw that direct engine DLL straight. As you can see here, I am using our standard window class in here, and I managed to get that working by adding a parent onto the end there. So the way that works, if we're coming into here, I have got a variable which is the m_parent for private parent, and we just pass that over in the constructor. And then when we come back here to create, if we have a parent, we are going to make it a WS child window. If we have a parent here, we're going to put it in, but obviously this was also default if we don't have a parent to null pointer, so we don't need to run a check there. All in all, our Echoes editor is working, and our standard Echoes game window is also working as well. I apologise about that. I accidentally just hit the wrong button, so someone tell me that we are back online. I need to close Echoes. Right, so that's where we are at, and today we are going to be looking back at our main Echoes window, and we're going to be starting to add DirectX 12. So before we go any further, let's say a couple of hellos. Hello, the one who burns. It's good to have you here, and hello, Clawquest. I know who Clawquest is. I was talking about Clawquest the other day. Hello, it's good to have you both all here. How are you today? What are you working on? I think this is going to be my standard question as we go forward. What are you working on? Because it's always fun to know what other projects people are managing to do. I think in this section what we're going to be doing is working mainly in our application. Not our application, our engine. Here we go. We have our initialize window. The one from the Twitch stream that was almost a year ago. Is that my Russian friend over there? So we have created in here our window. I'm going to just minus the... comment this out quickly so that if we set that startup window, so that if we do come in here and we are in release mode, we are not going to full screen just yet. There we go. That's just so I don't have to keep on alt-tabbing out to get into it. Hello, hello. Greetings, greetings from Barcelona to Russia and to anyone else who is watching as well. Greetings all over the world. So let's start building. What have we got here? We're going to be building in our Ethel engine. I want a new window in here, a new folder. I'm going to call this graphics. And in our graphics window folder, I'm going to create a new I'm going to create a new class. I'm going to call this render window. Now I've got this working and open in a different file here, but I think I can do this on autopilot for a moment before I have to start doing the boring part where I start copying and pasting things over. Namespace graphics, render window. That's good. It's nice to see people working freelance, being able to do something that they love, to be able to make them to make their way in the world. It's good to hear. Let's have a look. So we've created our render window in here. And our render window is going to have a public Win32 window, because we're going to parents off of this. Include Win32 window. As such, we are going to need a public constructor. Yeah, let's give it all. Let's do W string title, int width, int height. Perfect. Let's have a look at that Win32 window. Okay, that makes sense. So this should be f.graphics. And this should be f.graphics. And if I bring this across here, we should be able to then just... That shouldn't be needed. We can initialize our base class as such. Our base class is Win32 window, and we're just going to say title, width, height. Perfect. It's basic. It's basic. It just has an engine class at the moment. It creates. We have the window in there. Let's have a look at the engine class. So the question is, how is my engine structure? See if we can compact this down slightly. We have an engine class which holds the application and it holds the window. We have a extra struct class, which is engine initializer. This engine initializer is in charge of creating and assigning the application up here. And then we have a definition down here. And then if we go back into our echoes file, we have that's being used here. And what this allows us to do is to be able to have this class, which is external in a different library, at runtime when our engine starts. And we also have our main and WinMain functions down here. Main for debug, so console application comes up, and WinMain for WinAPI for release, so that the console application doesn't come up. No, I'm not planning on storing the renderer in separate DLL, mainly because you start having so many DLLs, you've got to make them read them from each other, they start having different dependencies, and so where possible, try and keep as little amounts of separate DLLs and libraries as possible. I chose a .lib for Ether, and I am using a engine DLL for DLL for the engine, mainly because from a .lib you can run these, whereas from a .dll you cannot. Right, coming back into here, let's have a look at this other working platform I've got here. Okay, so application is not what we want, and what we're going to do is we are going to upgrade our Win32 window now to our graphics render viewer. Graphics render viewer, we can get rid of this. Namespace, graphics, class, render view, render window. What I've just done here is means I can now get rid of this from the .engine file, .h file, and push it in our .cpp file. Not that one, engine. This one. Put that there, and that way we're not doing that bad thing where we are putting includes in our .h file. So there we go, render window. This is going to be again graphics render window. I believe that should roughly work the same. Get rid of echoes. Yeah, I mean, I specifically made this engine with the intention of making a singular game. This is not a generic engine. For example, my editor is literally named after my game, because I only intend to use that editor with this one game. It's an approach, but it's also an approach that I think a lot of game studios actually do. It depends, I suppose, if you actually wanted to sell your engine as a standalone, or if you were intentionally trying to make a game. And I'll be more than happy to just intentionally make a game, to be honest. Yeah. Right, okay, echoes. We don't need echoes. I'm getting confused. Let's go back to engine.cpp. Here we go. Window. Change this now to game graphics. Render window. m_window equals. It should do, shouldn't it? Why is it not though? Right, okay, I know why. Because I didn't put this, because I put this outside of this namespace, it doesn't take the original FR graphics, it was just taking graphics. So if we put that in there, then now this pulls correctly. This will create, voila, theoretically that's everything that we should need to have now created a render window. Thank you, that's the end of the stream. Goodbye. No, that's a joke. We don't need to go. Please don't go. While I remember, if anyone wants to go and like, haha, interesting. If anyone would like to go and like that like button, subscribe to that subscribe button, or just write anything in the comments, I hear as a YouTuber that these things really help. How is the weather? That's really annoying. How do I get my WhatsApp off of the screen? Right, okay, so we have our new render window here that works slightly too well. There we go. Let's go. Let's stop that. Come into our render window. Now, what do we want in our render window? First thing, we're going to want some public functions. So, let's go void initialize Initialize. There we go. Void initialize. Then we are going to go void update. And we might as well just do void shutdown. Let's create all of these. Minimizing the windows there has actually lost me all of my windows now, so I don't know where anything is. Still don't need this graphics. Why is that doing that? Render window, enter graphics. I have put extra sound effects on for you guys that you really used to like the beeps, and I think I am getting confused at those sound effects because I can hear my phone in my pocket going off, and I actually think it was probably on the sound effects. Right, okay, so without getting distracted by my own sound effects, I'll tell you what I'm going to do. I'm going to put some music on, and that way... There we go. If anyone can hear my obnoxiously loud coding music, please feel free to let me know. Okay, right, okay, so let's create another file here. And in our graphics, and I'm going to call this one DirectX12. While I'm here, I've got all of these hanging around and I don't like them, so let's just do some... Let's do some cleanup quickly. Application goes in core, engine goes in core, render window goes in graphics. Need a new one called Win32. There you go, they look a little bit better. And let's just add this one in ready. DirectX 12. Coming back up here, and I'm going to create a new class, and I'm going to call this one DirectX12. And this is just going to be a base class for all of our DirectX 12 items that we don't generally change. The way I'm going to do this, I'm going to have two different classes. One is going to be the render window. This one is going to change as we're building things. And the idea is that we're going to have this core class that I'm going to build it once and it's never going to change afterwards. So this is why I am just sort of double layering it. And although we called our class DXCore12, I'm not actually going to call the class that. Class file DXCore12. I'm going to call this namespace Ether Graphics DirectX12. What WAG could mean? Pretty sure we call our footballers' wives WAGs. Something similar to that. Okay, so this is our DirectX12 class. Again, let's make a public constructor. Should probably make a public destructor as well, or virtual core. Create those. Get rid of all this annoying namespace. We are gods. Okay. That's a very modest and with great humility. How about Memento Mori. Okay, got one of those. To make a deconstructor, I just need to copy and paste and put that there. No, I don't. I need to put that one there. There we go. Constructor, deconstructor. Now. Hello, George. Welcome. Welcome to the stream. We are looking at what we can do to get DirectX12 working. Just for anyone who's just joining in, we currently have a lovely pink window. And it's pink because I hate pink and I don't want to see it anymore. And that's the reason I kept it as pink, as a debug tool and also as motivation to actually get on with it. So let's have a look. We've got our render window, and our render window is currently inherited from Win32 window. I apologize for that, anyone who just heard me headbutting my microphone. But what we also want to do is give this one public graphics. Yeah, we can actually just go DirectX 12 core. We should be able to do that because we're already running it in AL. The reason we can't do that is because we didn't include it. Now, if you're being good, we should do this all the way from the beginning. So there, and when I created this, it has not gone. I want that in there, and I never actually used this engine folder, so let's delete it. And then DX Core 12. Choice, Burns choice. You can make lots of things static. There's lots of different options. This is the way I came up with in the last couple of days. I just sat down and wrote a little renderer. And really, while I'm live on stream, I'm probably not going to change that now. So. Again, I think calling anyone God apart from God is probably a way to get yourself smited. So in here, I'm going to create another basic function. We're going to say void initialize, because I love just having a function called initialize. Not going to declare it in here. Right, okay. What are you working on, George? Tell us about anything that you're working on, any projects that you're working on at the moment. In my initialize function here, it's going to start off slow and then we're going to build up to it. So let's start creating a new class, and we're going to start small. So let's go create, we're going to create debug layer. This should have, yeah, it should just have just about enough DirectX 12 for it to fail, for us to be able to fix that quickly to get us up to date. So this is saying if we are in debug mode, we want to create our debug layer for DirectX 12. As I am going through and adding all of these, I will explain what each one of them does. But for now, I think it's quite easy to see. If we're in debug, we're just going to call this function. At the moment, I'm running off of this DLL. Niels, how does a C# project editor work with a C# backend? A lot of handmade communications is how it works. There is Windows RT runtime, Windows runtime, which can actually mix C++ and C# together. But I find it's generally quite ugly and a little bit icky to use, so I generally just like to write the communications backwards and forwards, which means if you need to pull the information from one data variable, you just pull the information from a data variable, a bit like as you would be with a web, like a web page or a web server, where you just pull individual pieces of information, probably with non-blocking requests. Yeah, I'm not using WinRT though. As I say, you can get away without doing it just by having a DLL. So I didn't want to add parser generator. Do we mean you're trying to make Jarvis? Is that what you mean? You're trying to? Because that was one of my first projects, making Jarvis. Natural language programming. Take a lexicon. Try and understand the past words. What do you mean by a parser? Right, okay, so the first thing we need in our create debug layer is we need this right here. It doesn't like that, which is understandable. Let's go into Ether. Let's add some includes. So we have got the include for DirectX12. We have got the include for DXGI, DirectX graphics interface. I think it's good, DirectX graphics interface, but they DirectX 10, 11, 12, etc., etc., kept on having their own patterns. So they decided, because some of the functions of DirectX 11, DirectX 12, DirectX 10, etc., remained the same, they decided to make the DXGI alongside. From what this is what I believe anyway, of what I've been told. They built two different packages. One is the main code base, and the one is the one that goes alongside it. Just so that they can have a list of functions. So we've got DirectX12 added in here, DirectX DXGI, and the D3D compiler. So this is everything we need to start us on our journey. If we come back in here now, that has gone green, which is good, but it still doesn't know what a com pointer is. If anyone doesn't know what a com pointer is, it is a way that we can use a pointer that we can have safe releasing on. It means we can add it and remove it from memory very easily, safely, and that is the reason we use com pointers. If you don't know what a pointer is, I'm afraid I can't really explain that. It's about virtual memory. We're going way too far back in C++. Learn to use C++ if you need to know what a pointer is. Although, if anyone really does want to know what a pointer is, and I sound obnoxious right now, please put it on the chat, and I will be more than happy to explain it for you. As standard, the com pointer comes as this big long string here. So as well as adding WRL, I actually have no idea what WRL is. Windows runtime language? I really don't actually know what WRL is, so that unfortunately is lost from this tutorial. But we've got com pointer here. I don't want to have to write this every time, so minimizing it, which means we can just use it straight in the COM pointer here, and we can use this debug controller. Let's have a look to see if that is going to work. I think we should have a library error because we haven't linked any of the libraries across. Yeah, no, the mic has not gone. The mic was muted. Thank you very much, Niels. I don't know what I was saying, so I'm just going to get back on with it. This is the DirectX12 debug layer. Okay. If I was muted just then, I just added in the .lib files into here. It means I didn't need to figure out what it was going on the properties live on stream. Yeah, you're a star. Thank you. Right, okay, so DirectX12 comes with its own debug layer. This gives us the benefit of being able to print out error messages directly to ourselves so that if something goes wrong, we can get some feedback on actually what is going wrong. And it's really handy, so thank you very much, Microsoft. Right, okay, I'm going to copy and paste this across. Some of it across. I've got multiple, I've got a couple of different steps all in one application here. So I'm just choosing what I want to copy and paste at this stage and what I don't want to copy and paste. Okay, so this is quite rather easy to understand. First thing we're going to do is we are going to create our debug interface from our debug controller. We are going to enable the debug layer on the debug controller. I mean, this is not really as important as knowing that this will just create the debug, but I'm going to go through it anyway. And then we are going to take a flag for our factory, and our factory creates things, which makes sense, but we'll get into that in a moment. There are lots of things that we use our factory for, and lots of things that we use our factory flags for, and for this reason I want to store them for later, so I'm going to create a variable of that now. Hey, Dangerous Tuber. Thanks for the great feedback, and I'm glad you got that baseline. Did you manage to carry on with the baseline after the baseline? I'm going to put our factory flags in here. I'm just going to initialize this as 0, so that if we are not running this, it's always going to stay as 0, and if we are, we're going to turn our factory into debug mode. We're going to be using this for more later on, but for now it's a rather simple function. And again, it should just let us know that we are on the right track. Tell you what, one thing that I don't think we're doing, we're not actually calling any of this, so boom, yeah, the window works. We know the window works. Already 5 likes. Burns, are you on like police for the channel? I really appreciate that. Thank you. Yeah, like, comment, subscribe, join the Patreon. I don't have a Patreon anymore, I don't think so. I meant the Discord, sorry, but it's just it rolls off the tongue. Join the Discord. DirectX12 core, and we want to initialize. So doing it this way, what we're going to say is as soon as we get into our render window initialize, we're going to use our DirectX core initialize. And then let's just go back to our engine quickly. Make sure that our window is initializing. So let's just grab this here. Initialize. Perfect. Let's run that, see if it is compiling. I think the Patreon's still there. I just don't think it was ever monitored, because obviously you don't get Patreons when you're not producing. So I expect the Patreon is still there, but I think it's a little bit early for me to do that simping thing where I say, please go and join the Patreon. I'm more than happy that you guys are here and I can be working at the moment. Although, yeah, definitely something that I should be looking into, just as a matter of organisation. What do we think about the background noises, guys? This was a request from last week. I actually couldn't find the exact noises that I used to have on the old channel. I think I've got them somewhere on my server, so I'm gonna have to go and dig into that. But for right now, we've got some ambiance. Right, okay, I'm going to just put a little bit of a message in here, just so that I know that this is actually working. Pin I have a microphone stuck to my forehead, so I appreciate that, thank you. Yeah, Zachary, absolutely. If you could just place the reaction video and then a reaction video on that reaction video, that would be really good. Thank you. Debug layer created. I suppose we should. No, this is going to be only done here. So let's do this again. We're in our debug mode. Here is our window. This is going to give us some feedback. Debug layer created. So that's working, and we know that's working. Perfect. The next thing we're going to want to do is we're going to want to create our device, and this is slightly more complicated than just creating a debug layer. And for this, we are going to need some variables. So let's get this. Let's get this looking a little bit nicer. First of all, we want initialize, but I'm going to just put another public in there so we can break these up a little bit. Create debug layer, create device. We're going to want an area for our variables. I'll put these as protected for now. Protected, for anyone who doesn't know, allows you to access these. It's like a private class, but it allows the parent to access them. I'm sure there's some other very good uses for them, or better description, but that's how I remember them. I think if we do this more, the channel gets more. So I think if we keep doing these live streams and we keep getting more people, then I think the chat gets more fun on it. Or at least I've seen other YouTubers with more fun. So hopefully I'm quite close to upgrading. So watch this space. Right. Okay. So. First thing I'm going to create is a DXGI factory. Okay, we use our DXGI factory if we want to create swap chains and warp devices, specifically warp devices. And what that doesn't mean is it doesn't mean we've got the Starship Enterprise coming and Jean-Luc Picard, because what a warp device means is actually Windows activated render protocol. It basically means the it's going to be the day of me making up analogies, but it's definitely something to do with rendering. It basically means using your CPU as a graphics card. So we're going to create this factory, and we're going to create it as such. We're going to say that we're going to create the DXGI factory, and it's going to create it with our factory flags, and it's going to create it into this non-stored variable, because I could store this variable, but I just prefer to put it every time. There's not an amazing amount of difference. But we have ran into our first snag. Okay, to be able to justify whether these functions work, we want to be able to have some form of try, catch, or etc, and throw if failed is quite a good one. So create the XGI factory is going to return a H result. The way we could do this is we could say H result, sorry, my fingers are rusty. H result equals create DGXI factory. And then we could say if failed result do X. But I don't really want to do that. There's a quicker and easier way to do this, and there's actually a quicker and easier way which we can wrap this around with our debug layer so that we can actually get pop-ups if something goes wrong. So what we're going to do is we're going to put this back, and we're going to put it back into well, it failed. With a lot of undos, probably would have been easier just to rewrite it myself. Right, okay, throw if failed. So what we're going to do is we're going to come back into our DirectX12 folder, and I'm going to create two new files in here. Two new classes. One is going to be called DXException12. The reason I name them like this is just so that I know the file is going to be DirectX, and we are also going to be using DirectX11 just on our interrupt layer at bare minimum. So I might have things that are going to be the exception 11, 12, and it's just a really good way, or possibly even I wanted to cite like exception GL for OpenGL. If you just put that a little bit of more information, especially when you've got a lot of windows open at the top here, it just really allows you to narrow down. What do you want me, Niels? Do you want me to so Niels has put any DirectX developer is always going to use throw if fails. They all run on H results. Yeah, we're going to use throw if failed. Yeah, I could use if H result, but I didn't, and I'm going to throw my hands up and say that I threw this renderer together in a few days using Frank's code and the MSDN examples, and they all use throw if fails. So I apologize if if it's not original. Right, okay, so I'm going to add this in here. So again, as much as our class file is called DXException12, I'm not actually going to call it that. I'm going to call namespace ether graphics DirectX12. A lot of the code we are going to see today is just going to be a refitted public code. There is not going to be anything revolutionary on here, apart from the fact that I managed to get a pretty much full renderer with depth stencil and everything with the DirectX 12 interop and resizing and reset and re-establishments. That's about the only revolutionary thing we're going to see on here. Other than that, it's all going to be very boring code that you can probably pick up from any book. Today, at least. I mean, but we've only got so much time that we can spend on one stream, so. Okay, so we have got an exception class. Let's add another one in here. We're going to call this one DX Utilities 12, because again, everything is 12. Hey, loading your data. I'm always doing engine programming, yeah, just one way or another. But as I've said a few other times, I've wanted to come up with a new series for quite a while. But I think when you're trying to plan something like that, something big like that, you tend to spend a lot more time planning than you actually end up doing. So I just thought I'd throw us in here with some live streams and just build on the fly. And that way I actually get to spend some more time with you guys as well. And you can, if you've got anything that you can see that I might be able to improve upon while we're here, then you can just send it over to me live and we can fix it together. So this is a bit more like our engine than my engine, although it's very much my engine, guys. Ether Graphics DirectX 12. And we don't actually, no, we don't need any of this. I'm just getting in the habit. Right, okay, so let's have a look here. What do we need here? We need a file that is called throw if failed. And it's going to be this one. Again, nothing revolutionary here. I think I stole it. I might have actually stolen this word for word. This is yeah, absolutely. So this is let's actually do this one. So this was created by Frank Luna from his book, not owned. Just to be honest. What we need to do is we need to include our exception in here, graphics. Let me add this in and then I'll explain what it does. Right, okay, so we're going to say if failed. If we get an H result, which is bad, let me just nicely calm my cat down one moment. There we go. Right, okay, so if throw failed, if HR result is equal to bad, if it's failed, first of all, we're going to get the ANSI of the file. From memory, this actually gets the actual file. So in this case, it would be wherever the original file error came from. So if our error was in DXcore12, it will say DXcore12. If our error was in engine, it will say engine. And it is going to put the work file name in there. Windows file name, that would make sense, wouldn't it? And then if our HR fails, which is this up here, from here and here, we are going to throw a DirectX 12 exception. We are going to add the HR in here, which is the failed. We are going to add the X in here, which is... this writes whatever is X is to string, so that's going to tell you what function was called. What function the actual file was, and then what line it's being called on, which again is just... Yeah, I did forget end if, thank you. I caught that before I read that, honestly. Right, so throw failed, ANSI to W string. ANSI to W string, again, this is another one stolen. I have another one of these somewhere, and I think as we go forward, I'm going to create ourselves a full string class. Okay. Wide strings are the newer, more commonly used form of, or wide characters are for Windows. They add more data. However, some of the older functions still use ANSI characters. So that's your standard string is an ANSI character. And then a W string is a wide character. Sometimes we're going to need to convert them backwards and forwards. Right now, I only need to convert an ANSI string to a W string. So that's nice and easy, and I can do it there. Later on, I will make a whole strings class, however. And I know someone on the chat was actually making a F string class, so it can do a lot more fun. So yeah, I completely agree. It could do that, but it's not going to because I know it works. So yeah, I do completely understand that there is chances of a definition not being ever checked. But if you know it's going to work, then there's not an amazing amount of problem to it, is there? Right, okay, so though it failed, and for that reason we need to come back into our exception, and we need to fill this out a little bit more. I'm just going to copy and paste this across. You can also do it as well. It really is not wonderful code. So our exception takes the HR, it takes the function name, it takes the file name, it takes the line name, and then it prints it out to string. It has a function name, file name, etc., etc. At some point, I'm going to try and find a way so that I can on purposely break the engine so I can show you this in action. But really, there are more exciting things to show you than how an exception works. DirectX12, DirectX12, that works there, that works there. Go back into our utility class, which means our throwing failed works, and come back into here, which means we can come back into here, and our though failed is not working, but that is because we have not included I don't plan to plan is my plan. Okay. What am I going to do about events? Nothing right now. Nothing right now. I will look into it when I get to that point. But again, my whole idea was that I was spending way too much time trying to plan an engine without actually doing it. So at the moment, I'm just focusing on DirectX 12. Then I'll focus on something else afterwards, and we're just going to build it as we go along. So graphics, DirectX 12. Not exception. Why is that? That's because that is not in there. DX. Let's say, why is that working? DX utilities 12. I think there might be a very serious spelling mistake in here. I think. Yeah, absolutely. There was a very horrendous spelling mistake. For anyone who got that, clever person. Try this one again. So, utilities. Okay, perfect. I could probably put this a little bit bigger. Is that better for everyone? We can talk about it off stream, Burn. What on stream is definitely not good for is sitting around and planning. So, okay, so let's again go back to our core DX and check, and our throw if failed is. I've no idea if this is going to work. I mean, if anyone knows how to very quickly test a H result failure. What am I missing here? I'm missing something. String. String would probably be what I'm missing. Is that where are we? Exception. And are you? Yeah, there we go. Much better. Let's try this one again. I don't actually know how to test this, so if it's going to fail... No, it doesn't work like that. Okay, never mind. Never mind. It was only a test to see if I could get it working. Just to show you guys anyway. We don't actually need it to fail. Right, so the first thing we need to do is we need to create the factory. Okay, we don't actually technically need to create the factory at this stage. As I say, all we're going to use it is for our warp device. But just in case we need it for our warp device, we are going to create it anyway. And the next thing we're going to do is we are going to create our DirectX12 device. Now, let's add this in here so I can go into this slightly more detail. Throw if it's less than 0. Just out of pure point of testing. I want to try that now. There we go. There we go. Perfect. And that's brilliant because actually that has just made me remember something else that I need to do while I'm doing it, while I'm here. So let's go back to our main function. Not that one. Where did we end up keeping it? It's in our engine function here. Let's add here. What we're going to do is we're going to add our CRT debug flag into here, where we check for memory leaks. We're going to add it into... We're not going to add it into that one, because that one is for our release and this one is for our debug only. But what I am going to do is I'm going to put a try and catch symbol around our run function. Let's add in our DirectX12 include path. Come down to here. Okay, so we're going to try and do everything in the engine, but if not, we're going to try and get a DirectX 12 graphics exception. I also... Yes, I get with the failed macros, absolutely. If you want to go back and rewrite this with no definition, no defines at all, before the next episode, then I'll be more than happy to give you the credit for it. But at the moment, it works. Right, okay, so we've got our try catch. We are running a DirectX 12 exception, and we are writing up. Now, if I do this again with the -1. Here we go, and then we get this little pop-up. So -1 failed in here. unknown error because we're not actually making a DirectX12 error. And again, this just gives us a lot more ability. And if we actually click OK and come to output, you can actually see we're also going to get detected memory leaks, dumping objects. We're actually going to get more information down here as well by adding this and this here. All of this, and I haven't even created the Direct 3D device, but it's okay. This might be a long stream tonight, guys. But I'm going to keep going if you are with me. So what we're going to say here is we are going to say we want to create the DirectX12 device. Now this is the variable that hooks directly into our graphics card. Okay, yeah, I'm going to say this is the variable that hooks directly into our graphics card. When we are assigning this, we are basically going to say that we want to choose which graphics card we are using to publicate this variable. It is not your graphics card. You can't think of it that this is the variable is the graphics card. You can't have that thought really, because you can actually create multiple of these that will all connect into the same graphics card. So it's not like a static issue, but this is the best ways to think of it. This M under device will represent your connection to your graphics card. In this, we are going to say that we are going to want to create a device, or create the device, which is M device, and we are going to give it DirectX12, DirectX version 11. Why? Mainly because I was never using DirectX12 features, so I never needed it. But hey, let's put it up to 12, just because what's the point in using DirectX 11 features in DirectX 12? Now, we're going to say here that if we try and create our device and we cannot find the correct graphics card, now this null pointer here is actually represents give us whatever graphics card you can find. Okay, so if we've used give us whatever graphics card you can find and we've not found any at all, then what we can do is we can fall back onto our CPU and say, look guys, we don't have a GPU, but can we get away with using the CPU? And for that we can call a warp adapter. For this, I am going to keep it a DirectX 11 feature set. Okay, why? Again, I don't think it really matters. We are well beyond getting anywhere near any of these feature levels. So we have created a device. We have, if it fails, we are creating a warp device. The next thing we want to do is we want to actually create some command objects. That's what we did, didn't we? I didn't actually create the factory. Create factory, create factory. We need the factory here. So this is the reason we created it in the beginning. We need it to be able to create that warp adapter. Create debug layer, create device. Next thing we need is we need to create our command object. There are 3 different command objects that we need to create. We have the command queue, command list, and the command allocator. So what I'm going to do is in future episodes we're probably going to be breaking these down so that each different area has its own command allocator or command list, etc. Generally you only have one command queue, but each have. But for now what we're going to do is we're going to create more of a static global one for us to use while we don't have to complicate things. So we need our command objects, and I'm just going to throw these here down under M_device. Again, we have a command queue. I'm going to call this one direct allocator because we could have, if we were to add frame resources later where we were using different frame resources for each frame instead of using the same, we would have different, and this would be a list. At the moment, because we are going to use one of them and we're going to go for quite a basic setup, I'm just going to leave this here and I'm going to leave it as a global function. If we add more in later, I can still leave this here. It's fine. It won't make much of a difference. So we need a new function in here called create command line objects or create command objects. It's certainly not the easiest thing in the world doing all of this live, especially when you're focusing different areas at different ones. So I appreciate that you appreciate it. How are we doing today, Harish? How are you doing? Okay, there are different types of command queues. Okay, we can have... There are different types. I don't specifically know what they are. Let's have a look. Here we go. Oh, no, that's command. We need command queue. Ah, yeah, bundle, compute, queue. Okay, so bundle takes in a lot of things at a time. Compute is mainly just for doing calculations. Direct is what we would standardly use. Video is a little bit beyond me. We'll learn that as we go along. Right, okay, so we're creating a command queue desk. With DirectX 12, it really is all about this. And this is the difference between DirectX 12 and DirectX 11. In DirectX 11, everything was done on the back end. You said, I want to create this, and it created it. Happy days. In DirectX 12, it is a low-level language, so everything expects you to tell it how to work. Whereas DirectX 11 just expects it to know how it works. Now you have to tell absolutely every single thing. So we're going to find ourselves with a lot of these, this function where we want to create something, but first of all, we have to create a structure to tell it how we want it to work. We are going to create our command queue. Now, our command queue is the queue that directly... Command queue is the queue that directly speaks with the graphics card. So you can attach multiple command lists to a command queue, and then in that command queue will slowly pass that information over to the graphics card to be able to be done. Yeah, absolutely. Computers for computer, yeah, mainly for doing calculations. Copy. Okay, cool. I don't think I've used that one. Command queue sends messages to the graphics card. The command allocator is what we use to add commands to the command queue, and our command list is the list of commands that we want to add. One moment. Generally, you have one command queue. Okay, as we've said, you can have multiple different command queues for different yeah, you can have different command queues for different things, but mainly you just use one command queue. You then use a command allocator depending on where you want the information to come from, and you can have multiple amount of command lists depending on what you want to do. So you can have one command list which is control of rendering, you can have another command list which is in control of your background rendering, for example the environment or the trees, etc, etc. Once we've done all of this, DirectX 12 has a very big problem with not being in the correct state. So we are going to have to reset the command queue and the command list and the command allocator at the exact right times to be able to get this to work. So what we want to do is we just want to start with our command list closed. So we're just going to add that in there. Here we go. This is very much a I do live stream, guys, so I apologize if the tutorial level of this is not the same as it would be in one of the videos. Obviously, with the videos, they are not directly scripted, but they are heavily researched, and I know exactly what I'm saying, whereas I'm doing all of this live and on the fly. So if my descriptions are not as good as usual, I apologize, but hopefully you can see from what I'm doing instead of what I'm actually saying. Right, okay, so the next thing we are going to be creating is our fence. Now, our fence is an item which allows us to have a signal between the graphics card and the GPU in order to be able to ensure that they are both working at the same time and they are not running over the top of each other. Okay, so basically we fire something on the CPU, so fire something on the CPU. We will then set a fence, we will let the GPU work, and then we will recognize when the GPU is finished so that we can then again start the CPU over. So let's have a look in here. For this, we are going to need a couple more variables, but let's just get the fence created for now. Okay, so we're going to use our DirectX12 device to be able to create this, just like we did with most things. And we need a variable, which is going to be mFence. I'll catch up with you on the Discord, Burns, and yeah, we'll have a look at that as we go through on the week. But you have a wonderful evening. Thanks for tuning in. Right, okay, so let's have a look. I need the variable for our fence. And let's put this in here. I'm not explaining or reading out exactly what these are. They are generally quite basic. They all start with ID3D12 and then command Q, command allocator, fence, etc. So I'm sure you can read from the screen exactly what each one of these is without having me to explain it. We're not going to add any flags on here, and we are just going to create this basic. We're not going to do anything to it. We will need to do things to it later to make it work correctly, but for now, we just want it created and we want it ready. The next thing we are going to do is we are going to create our descriptor heaps. Create descriptor heaps. One thing I can tell you is that I have spent the last couple of days just making sure that this is perfect and working. So it definitely works. I might not be able to explain every step of it perfect, but I can assure you that in general the render is definitely working. So even if not everything that I'm saying is available and easy to follow, if you just copy everything as I'm writing it, it will work at the end of it. I promise that. Right, okay, so we need our descriptor heaps. We have two different forms of them at the moment, but before we do that, I am just going to add in this variable here, just to make it easy, and we are going to grab this, and we're just going to put this nice and far up the top, because this is a static const, and we're going to say frame count 3. Now, quick lesson in how graphics works, okay? You always want more than one frame rendering at any one time. We never render one frame, wait for the end of the round, then render another, then wait for the end of the round, and render another. Because what you would have is you would have flickering happening between one frame to another frame's transition. And it would be in generally quite visible as you have to wipe the screen, bring it up, wipe the screen, bring it up. So what we would generally do is we have multiple frames that we render, and we render some in the background, some are in the front ground, and then we just swap those over in a swap chain, and we'll get to the swap chain in a moment. But that way we can reduce flickering, we can reduce anomalies on the screen when we do it. Okay, so in this case we're just going to use a frame count of 2. We're going to have 2 frames rendering at any one time, the back one and the forward one. We can update this to 3 if we need at any point. So now we've done that, the first thing we are going to create is a descriptor for our render target view. Now an RTV, or a render target view, is the actual render screen in front of you. Okay, this is where we are going to be adding our basic graphics. Okay, this is our canvas as it was. We have to say how many of these we want to create, so we're going to create we're going to create 2 in here, and we just have to say what type it is. You'll notice that both this one, which I'll explain in a moment, and this one have the same type, so we need to say what type of descriptor we're using. There's RTV, there's DSV, there's CBR, there's UAV, there's quite a few of them, but I will explain what they are in a moment. This one here is generally needed for most implementations we're doing. If you're working in 2D, you don't necessarily need this one. I'll explain in a moment, but if in most applications you're going to need your render target view, because we're making a renderer, and that would make sense. So we're going to need a couple more variables in here. Let's have a look. So we need to not only remember the description of our heap variable, okay, and it's called a heap because this is going to be the information sent across to the graphics card, because it's a heap of information sent to the graphics card. So our render target view is here, and we need to know exactly the size that we are going to use. Another feature, I believe, of DirectX 12 is the fact that you need to now manually keep the size of each heap. And this is not only just DirectX 12, every graphics card that you use has a different size of storage. So by grabbing this, we can say not only is this what we need in our program, but this is what you need for your computer to work. That being said, this is, from that description, really easy. It's an RTV. We have to set the flag. We add no flags. We need to create a descriptor heap. It is going to be our RTV heap. Done. We needed it. We created it. Boom. Same. We needed the size for later on, so we grabbed the size of our descriptor heap. There. So this is our render target view. We are going to now do the same for our depth stencil view. And what our depth stencil view does is it allows us to register where the pixels are in depth on the screen. Now this means that if you have a box or a cube that has 2 sides, one in the forward and one in the back, during rendering we are going to register that the face on the front is further in forward than the face at the back, and therefore we are only going to render the face at the front. If we don't add a depth stencil view, it gets a little bit funny on the screen. So this is why we're going to add a depth stencil view, and I want this to be 3D. We're not going to start off with the triangle. I'm going to get at least a box started off in the next couple of days, or the next couple of episodes, so we're going to act straight off with a depth stencil. We need a descriptor heap, just the same as up here. We're going to call it this. Number of descriptors 1. we only create one depth stencil. As much as we need multiple render views to be able to update, we only need one depth stencil. So we're just going to keep that to number of descriptions 1. It's of type DSV. We don't add any flags. Not really sure what this does, so let's not even talk about it. And then we throw it failed here. We need our heap and we need our size. So let's add that now. Again, this is mainly to store how we want the information to send across. It's the description of how we want to send the information across. It's rather boring, but it is needed. Did I just call that descriptor heaps? That should be create descriptor heaps. Create descriptor heaps. Right, as it goes, I believe those are the majority of the items that we need to be able to implement into our back-end engine, as in this DirectX Core 12 class. And I don't think we're going to change it from now on, which was my objective of creating this parent class here. Let's just have a quick look, so compare it to the one I've already got. One or two extra functions in the in the one I've created, but that is on purpose that I've not put those on. I'll probably go back and comment off all of these in the next section, or off camera. I think is probably the best thing to do. And what I think I'm going to do is I am going to take a quick 10-minute break, and then we'll come back and carry on getting this renderer working. So definitely time for a cookie, for a biscuit, and today's question: what does everyone do for work? Let me know in the chat. Let me know in the comments. I will be back in 10. Hello, so I am back and I am ready for part 2 of this tutorial. I have spent most of my time currently working in this core file. Again, this is going to be an area that is probably not going to change, so I can put it all in there and just leave it, at least long term. No, you got all good? Yeah, absolutely. Good, thank you, Thomas. Good to see you, by the way, Thomas. Right, so as I say, this area is probably going to be an area that I don't want to use, so theoretically we can close this down. And while I'm here, let's just go through and let's close half a ton of this down. I'm probably going to need that at some point, but I don't need it right now. Exception, probably never going to need it again. F is handy to keep open. Let's get rid of engine.h, get rid of window.h. Again, I might want to change that at some point, but render window, engine. Into Office for our DLL file. There we go. That makes it just a little bit easier to see what's going on. And in that time, I got a well-needed cup of coffee because you can't code without coffee. In here, I want to create our swap chain. Okay. Each different window you should create should have its own swap chain. That being said, our core folder, if we create this multiple times, it's going to create all of these variables multiple times anyway. So it doesn't really matter where we were to store our swap chain, but going on the idea that every file, every different window we have should have its own swap chain, I'm just going to build on this from here. So let's come into here and let's add a new variable, which is going to be our swap chain. Now you'll notice this is not the standard function of ID3DX. Anyway, it's not the standard one. This is a DXGI, and for that reason we actually need our factory to be able to create this, not our engine. So this is one of the reasons we saved our factory flags earlier. What we want to do now is we want to create our swap chain. We don't have a function for that, so let's come down here and let's create ourselves a function for that. So void render window create swap chain. Now we've created our render target view heaps, and these are going to be what stores our information. In a moment, we're actually going to create our render targets, not the heaps of them, the actual render targets themselves. And then this swap chain is going to be what then swaps them backwards and forwards as we are rendering to be ensure we have really good super duper graphics. A swap chain actually takes a fair amount of setting up. So let's go through this one step at a time. Let's just add that there. Okay, so just the same as we did with some of the previous things, like our render target view heaps, we need to create a descriptor for our swap chain. There are multiple different types of swap chains. They go up. There's swap chain 1, swap chain 2, swap chain 3. And the same as there is a factory 1, factory 2, factory 3. It gets complicated. Each one has different levels of features, but I'm just going to use this one. I think this is the example that was being used in the MSDN examples, which I mainly went through. I do very much rate Frank Luna's examples, but I just prefer the methodology of the MSDN, so I have a tendency of mixing the two together when I'm just knocking this together for our engine right now. Our frame count is what we added earlier, but this is not coming up. So this was obviously a private variable in here. So let's just, let's just put that there. There we go. I kind of like these publics, and I just use them to separate my areas of doing. Let me know in the chat if anyone else does the same. Right, okay, so we've got our frame count in here. So we've got a buffer frame count. That's how many times we want to, how many render targets we are expecting to keep. We've got our width of our render targets, which is our width. We get this directly from our window class. Okay, so this is built in, and we can change that at any time if we want. We've got our height. I won't bother opening it, but again, that comes from our render class. We have the format in which we want our renderer to run. Okay, in this case, it's going to be RGB8. RGBA8. Okay, there are multiple different ones. I've never really tried different ones. Feel free. There's multiple different uses for multiple different formats, but I'm not going to vary from that. Okay. Swap effect, flip, discard. Basically, what it says it does, it renders it, it flips it, and then it discards the back one that is just used. Okay. Sample desktop count. Not going to get into it. Either way, we have now created ourselves a descriptor for our swap chain. As a swap chain is a DXGI object, we are going to need to add in our factory. Okay, so this is just though failed is undefined. Include the graphics. The reason I do this all the way back from the beginning every time, even though we're in the same folder, is so that if we draw this from another library or another program, it can also read it just from the beginning. So anything can access this from there. Utilities. Throw it failed. Right, okay, so as we're going to be creating a swap chain, and as this is a DXGI object, we also need a factory. So we're just going to create that. This is what I mean about factories coming in multiple different versions, and this is also what I mean about DXGI coming in multiple different versions that don't always match up with the DirectX level that is actually on the market. The next thing we are going to do is we are going to create our swap chain. We are going to have a temporary variable, which is a swap chain one. We are going to use our factory that we just created to create that swap chain on this handle. This handle again comes from our Win32 window. This is our HWND that is created on create window. We need to get our command queue. We're going to use .get because we want the actual command queue. We don't want the com pointer, we want the actual command queue. So we're going to use .get. This is the description of how we wanted it to work that we had to put in here earlier. We've got two other functions in here, which are, I have no idea what that is. Full screen description and a DXGI output. Interesting, I don't specifically know what they do, but they're null pointer at the moment. And then we are going to declare that on here, because we're going to say we create it and we need somewhere to actually create it. So we're going to create that on here. And what we're going to do is we are just going to recreate that as our swap chain. Now this is a swap chain 1. This is also a swap chain 1. No, this one's a swap chain 3. Okay, so we're going to create it as a swap chain 1, and then we're going to redefine it as a swap chain 3. And again, just because these have different functions on it, most of this is copied and pasted from the examples. So what the original intention of this was, I don't know. But again, we're creating a swap chain 1 here. We're creating it with the swap chain 1 functions, and then we're recasting it into a swap chain 3. If we are going to be swapping backwards and forwards from our different render targets, we need to have a way to be able to keep track of which render target we are on and when. So we are going to create this variable, which is our frame index. And we're just going to put that down there like that. So we're going to make that into a uint. And we're just going to initialize it at 0. Right, okay. For this, we're just going to add this in here. This means we can't alt enter to make it go full screen. Our release copy will make it go full screen because that's what we told our that's what we told it to do. But although I commented it out at the beginning, although this is just going to stop the alt enter functionality for now. Again, not really needed, but it's just there. And we have created our swap chain. I think the best thing to do now is just to run this. Let's just make sure we've got no errors as we are currently. This is everything that we need to actually create and initialize DirectX 12. So if this runs nicely, that means everything is actually working and everything is now initialized. We can't see it, we're not rendering, we haven't actually asked it to do everything. But this is pretty much everything that we need to do to set it up to start with. The only other things we need to do is set up our render targets and our depth stencils. But we need to do that every time we make a change to the window. So for example, if we are running at a 600 times 800 window and we want to make it go full screen, if we do not recreate the render targets, resize the swap chain, etc, etc, the benefit of going to a higher resolution will not be visible on the screen because it will still be running on the lower resolution. So what we really want is we want a way to be able to reinitialize the window every time the window is changed or realized, and we want to be able to reset all of the previous variables that we didn't want and create everything anew. So that's what we're going to do. We're going to create a reset function. I am going to, at the moment, I'm going to put our reset function here in our initialize function. But later on, what I'm going to do, I'm going to take it out of this and I'm going to put it into our actual resize functionality, and that will mean that as the window is created in the first place, it will resize and then it will call the reset. Let's come in here and let's create a new function called reset. This is also going to be the same function that we run if we want to change level. Okay, so for example, we have a level in which we have 100 objects loaded in and the rest. We would also use our reset every time we change levels to wipe out all the previous items that are stored in the swap chain, not swap chain, command queue, command list, command allocators, etc, etc. Okay. Basically, let's reset everything back to start and create it again. Not everything we've created, just what we're going to create from this point onwards. This is going to be an extra long video tonight. I don't think there's any way I can get a full implementation of DirectX done in a couple of hours. So if my voice starts getting more and more croaky through the evening, I do apologise. But I do have a cup of coffee in my hand, so hopefully I will be more awake in a moment. We have just created a reset function, but we didn't actually create it in .h, so let's do that now. Again, this is not exactly how I want this to look, so let's put the initialize, update, and shutdown here. Let's put public here, and this defines that these are our sort of like external, these are sort of like our internals. Could put them as private, but I don't know if I might want to use them later, so I'm just going to leave them for now. And we'll get into our reset. The first thing we are going to add here is a command that we're going to call flush command queue. We want to make sure that when we are resetting, there is no information left on the command queue when we start resetting items. Because if that happens, we could cause a catastrophic crash or etc, etc. So basically we just want to be able to make sure that there are no commands left on the command queue before we start resetting. So let's just flush command queue before making any changes. And we are going to create a new command. So flush command. This is another one of these commands that is pretty much copied and pasted from the examples. Okay, it's there are other ways to do it, which we will learn later on, because this is only a command that we're going to be using very early on. But honestly, I don't think I could have rewritten this if I tried. It pretty much is a one size fits all code script. So I'm just going to copy and paste this over. We have a fence value, which is in here. And while I'm here, let's add in a few other features here. Where's my frame index? Did I put that in here? Yeah, I did. Yeah, frame index can stay in there. But I do want a fence value. There we go. Just going to be a uint. And I generally quite like to just put all of these in a row so that you can see what they are and what they're all called really nice and easily. Okay, so flush command queue. Make sure that we have no more commands left on the command queue. First thing we want to do is implement our fence by +1. Okay, that means we're basically adding a value to check for. We are going to send a signal from our command queue to our fence. Basically, we're going to create a fence. We are going to say when this is the completed value, if the completed value is smaller than the fence value, we've just incremented this, we are going to run this. We are going to create an event which is a handle. Okay, when we are going to use that to ensure, and this is going to ensure that we are completing that event. And then we're going to wait for single objects, close handle, which destroys it all. And it's just basically we're going to wait until the GPU is finished processing before we move on. That's all this does, but again, it just ensures that our CPU and our GPU are always in that perfect tick-tock, tick-tock, tick-tock. I don't think I could have rewritten this if I tried. Although I think this is Frank's version and not the MSDN examples. Most of this is the MSDN examples, apart from the extra bits which I stole from Frank. For anyone wondering why I didn't just grab this from my own engine, it's because I just didn't have one to hand. I've got a few written up, but they were all going to be way more complicated than needed. So I thought it'd be easier just to spend a couple of days just working on this and getting a new one for us now. Flush command queue. Flush command queue. So the first thing we wanted to do was flush the command queue, which we should now have successfully done. Find out where I was in my example code. The next thing we want to do is to ensure that the command list and the command allocator are also reset. We want these at their base level as well. So we're going to flush the command queue, and then we're going to reset the command list and the command allocator that is assigned to that command list. The next thing we're going to do, and this is going to seem a little bit backwards, because obviously the first thing we need to do is destroy something before we can create it. So we're going to be resetting things before I explain that we're adding them. Okay, so bear with me for a moment. The first thing we need to do is we're just going to make a quick for loop, and we are going to do this for our frame counts. We need to add in a couple more things in here to get this working. And these are going to be our render targets. said before that we are going to have a render target view heap and a render target. We've already created our render heaps. This is the general information of the data that our render targets use. And now these are the actual render targets themselves. So when we're actually rendering, we're going to be doing it to these rendering targets. We also need the depth stencil buffer. This is the render buffer that we're going to use for our depth stencil. So we need a IDE i3 resource for that as well. As soon as I can find it. So to backtrack quickly, in our DX core, we have created our descriptor heaps. This is how we want to create it in the future. We've got a render target view and we've got a depth stencil view. Then in our render window, we've got our actual render targets and our actual depth stencil. Before we can reset those, or before we can create them anew, we need to make sure that they are empty and not being used. So the first thing we need to do is actually just to reset these, just to make sure they're not being used. So let's do that in there. And then we're going to grab the depth stencil buffer and we're going to put it underneath, because there's only one depth stencil buffer. Again, we've got two render targets currently because we've got the front screen and the back screen, and we've only got one depth stencil buffer. So we're going to reset that. The next thing we're going to do is we want to resize our swap chain. This is mainly what this is for. I said earlier it's going to be very beneficial if we change the screen or change the window that we're on. So if we go from 800 to 600 and then change to 1240 by 720, for example, we want to be able to register that, and it's not going to do it automatically. So we have to actually give it a command to say we want you to resize the swap chain, please. This command can be very dangerous. To be able to resize a swap chain, you need to ensure that all of your information has been closed and reset ahead of time. So for example, you can see we've reset this, we've reset this, we've reset this, and we've flushed this. As we go forward, there are going to be more items that also need to be removed before this can be ran. So just be careful. This command here can cause you a lot of errors if you are not removing things before you are running it. And again, this is going to be ran every time we change size on the window, so you need to make sure it's done correctly. As we are resetting everything, let's just make sure our frame index is back to 0 as well. To be able to do this next section, I'm going to need to add another class into here. DirectX12 comes with an entire set of classes available for you to use. However, it's extremely low level. That means everything is done manually. Thankfully, although the engine was kept low level, the people at Microsoft decided to give us a little bit of a benefit and just give us a one-page script in which we have building structures, which just helps us out slightly. So this would have once upon a time had to be made in lots of different items, but thankfully, thanks to Microsoft, we can just take one file that you can find in all of the examples. It's in MSDN, it's in Frank's examples, and we can just add this in. So this is called D3DX12.h, and I am just going to copy and paste this entire file over. And this is 4,000 lines worth of a file. Again, get it from the MSDN, get it from Frank, get it from anywhere you need, but it's always available. if we then go back into Ether, and what I'm going to do is I'm just going to include this in everything we do. Yeah, it just means I don't need to include it multiple times. If I was thinking, then maybe I wouldn't be including this here, but it's what all of the examples do, and it's what my head thinks it should be done, so this is what we're going to do. So where are we, and why are we? As much as we've got our render target view, and this is one of the reasons why DirectX12 is so complicated, because you need one thing to power, another thing to power, another thing to power, another thing. We have our render targets, and for our render targets we have our render target view heaps, and then for our render target view heaps we have a render target view heap handle. You don't really need to understand what all of this does, but as long as you understand where it's used and how it's used, then that's fine. Just knowing I need this here to put this here is enough without you needing to know every single one of what these do. Okay, because I can use it and I don't. So I think that answers that question rather simply. The next thing we want to do is we are going to make a for loop over our items, and we're going to actually create our render targets. Our render targets, not our render target heaps, not our render target handles, our actual render targets themselves. So first thing we're going to do is we're just going to use the swap cut chain to get hold of our render targets 1. Just add that in there. And then we're going to use our device to create the render target view. This one adds the render target view to the swap chain. This one creates the render target view using the render target view heap that we created earlier, but it won't allow you to just provide it with the heap. You actually have to put the heap in the handle, which is why we have to create this one first, which references this one, so we allow it into here. So this one creates the render target using the device, using the render target heap. This one here creates the render target view on the actual swap chain. And there's one more here. And what we need to do is we just need to offset that heap handle by our descriptor size. We said that every graphics card has a different descriptor size and that every application could have a different descriptor size. This is why we need to keep a log of it, and we need to just now grab that handle and just offset it by that amount. What we have just done here in this section is we have just created our render targets. Okay, again, not our render target heaps, which stores the information, not our render target handle, which stores the render target heap, our actual render targets. If this is long and hard work, I apologize. Feel free to mute me and just watch what the code is doing. It is a long and arduous task. So believe it or not, to create a depth stencil view, we need to create a depth stencil description. Okay, everything comes with a description first, and then we use that description to actually create the item. So let's start off with a depth stencil descriptor. That is going to be a resource descriptor. I'm going to add a lot of these in here. The dimension, it is 2D. We do not need third degree dimensions in there. Alignment is 0. It is going to be correctly aligned. Width, height, 1. MIP levels, 1. I'm not going to explain any of this. I'm not even sure I explain half of it, and I am getting to the point where I am losing my voice. But I'd really like to get this done in one day. Even if everyone who is watching right now is having problems keeping up, at least it will all be recorded in one video and you can come back to it. Right, I'm going to copy and paste all of this in here. Let's have a look at this all in one piece. We have our Dental Steps resource. What have we got in here? The format needs to be the same in everything we do. This one is typeless. We'll find it again somewhere else. So that needs to be the same. Again, this is the same as when we chose our RGB8. They're different formats you can have. They perform differently. You get to choose, but we're going to stick with this one. Sample desk 1, quality 0. That is your anti-aliasing. Anti-aliasing is not very good at this. So at least on our first program, I'm not getting involved with it. So this is why we are just setting it to its lowest level. And a flower depth dental. There's a second descriptor there. I'm not really sure what it does. I know this creates a depth stencil. Like, knowing every single bit is challenging. I'll try and explain everything as best as possible. This here, CD3DX12 heap properties, is another one from our DirectX12 given to us by Microsoft. So basically, it does all of this for us instead of actually having to do it manually. Anything where you have the C in front of it generally comes from this file here. We are going to create a heap property, and we are going to move that resource onto the pipeline. How does one explain this? We're going to move that resource onto the pipeline. This is a heap type default, which means once it is uploaded, it is not going to change. There are other type heap types. Heap type upload, I think it is, off the top of my head, means you can change it every round. But we're not going to change this, so we are changing it with a default heap, and it goes directly to the graphics cards, never going to be changed. No flags. Our depth stencil desk is this here. Resource state common. Not getting into that right now. Opt clear is this here, and our depth stencil buffer is again our actual resources, our actual depth stencil buffer. Create depth stencil view. This one uploads it, creates the heap. This one creates it. And this is a transition. So a transition, unlike DirectX 11, in which you could just straight move from one section into another, now the command list must know what type of state your command list is, okay? So, or each item is. So it makes it so that you can do more functions in one time without having the background engine keep swapping when you don't want it to. But it does now mean that we have to add in a transition in the right places at the right time to make it work. So in this case, we are going to transition our depth stencil from our common state to our write state, which means in a moment we're going to be able to write to that, and then we'll be able to transition into a present state, which will allow us to actually present it and render it to the screen. It's complicated, it's just there. It's one of these things you just have to learn. To be able to use your resources, you have to transition them correctly. That was way too much on depth stenciling, and I don't even think we're going to use it in this episode, so I just want to move on very quickly, and this is getting very long for us all, I'm sure. Once we have once we have reset everything, we have resized our swap chain, we have created our render targets, we have created, in a very long copy and paste session, our depth stencil view. The next thing we want to do is execute our command list. So all the things that we have added onto our command list, all the creations, etc., let us send those and execute them. Okay, and then after that, we are going to flush our command queue to again make sure we are back to a basic state, which will allow us to get onto our next section, which will be rendering. I'm not going to take a break for this. I'm going to move straight onto rendering so that we can try and get this done today. But yeah, so this will then put us in the correct format where everything is empty and ready to receive commands, or so that we can render. So that we can render. That reset is there. That reset is there, which means I should now be able to hit play and everything should be working successfully. Which is probably the worst thing you could say while you're waiting for something to compile. Interesting. I think as we go forward, we're going to get even more of these. But I could put this in conformal mode, which is what I did for the example text. But I think it's also handy just to know how to fix these. So let's just go auto default heap equals this here. And then we go default heap. When I created this engine, I put us onto the newest version of DirectX12, of C++. And the newest C++ has an issue with R values versus L values. These are values which are pointers versus values which are actually available in memory right there and then. Because this is pulling from a function, it is not liking it as an L value. So if we just say that we want this would also works like this: CDC heap properties default equals, but just for the sake of it, I'm just going to put auto equals this. It means we're creating it right here and now, which means we can use it without pulling an L value issue. And the other is not there. That's 153. 155. That is saying that this here, second argument, should be a L pointer. Should be a LPC W string. It is a pointer W string. So instead of bool, let's just put that into there. Now these came directly from the MSDN, examples. So if you try and run this without conformal mode on, with the latest version, you're going to get all of these errors. So it actually gives us a hello, Wallababies. How are we doing tonight? Yeah, you're going to get all these same errors, so it's good to know. There are definitely going to be some sticklers in the here watching, thinking, I want to make sure I can solve every single issue in here. So again, done exactly the same here. Just created an active transition based on the resource barrier and put it over to auto. Added that in here, and that should solve all of our current errors. Although someone can remind me the next time I go to hit play that I need to stop saying that as I hit play. Voila, we have a compiling code. Now, that is everything. I said it before when we finished our core class, but that is everything we need to initialize DirectX12. Okay, we have created our device, we have created our command objects, we have created our swap chain, we have created our descriptor heaps, we have now reset everything to the newest functions of our HWND, our window, in which we have resized that swap chain, we have created our render targets, we have created our depth stencil. There is one more thing that we need to create. I've just remembered. We need to create our viewport and our scissor rectangle. Our viewport is rather easy to explain. This is the viewport as the camera renderer, graphics card sees it. And your scissor rectangle is the area outside your viewport that needs to be cut off. So for example, if you had 100 objects in your scene, but you only had 3 in front of you, the scissor rectangle allows you to only render the ones you can see. Because we have put those in, we are going to need to actually define them, and we're going to do that in our reset function. Nothing fancy to see here. We're just going to say top left 0, top left, width, height, minimum depth 0, max depth 1. That generally means all of it. Okay, and our scissor rectangle again is just going to match our screen height. Let's go back to our engine class, because in our engine class we created our window and we initialized it. But what we didn't do is we didn't set it to update. So let's just run an update function here. Go back to our render window. Make sure that I'm actually got sound and I haven't been recording myself talking to myself, or not recording myself talking to myself. Okay, and now we are going to need a function. We are going to call this render, and I'm going to put it up here just because render is more important than updates, and I like to keep them two together. So we'll just keep update and shutdown together. We don't need render window, we just need render. Create that. Okay, and in our update function, we are going to say render. We might also want to do other things in our update function. This is why I have not just hooked directly into the render function in the engine, because we might want to do things to our actual variables, update them over time, etc., etc., which is why we have an update function. But we also want to render, which means is why we have a render function. The first thing we want to do when we come into render is grab a cup of coffee and have some of that quickly. One moment. First thing we want to do when we come into render is we just want to reset our command list, our command allocator. So let's just go command allocator, get rid of that, and then let's reset that on the command list as well. What we want to do now is we need to transition our command list, our back buffer, which is our render target. So let's go. So our render targets, but we want the specific render target of the frame we're on, and we want the actual value, not the com pointer. And we want to transition that from state present, going on the idea that if this was multiple times rendered, we would be on state present because we would have just presented for the previous frame. We now want to move this onto state render, or render target means we can now add information instead of presenting it. This becomes quite rather easy later on, and you can, I didn't do it for this, but you can create quite a nice wraparound function for that works really easily. So including your L value issues. So either way, we want to take our render target and we want to move it from state present to state render. We now want to set a couple of functions of our render state, okay? i.e. we want to set the viewport and the scissor rectangle, and we just added these in here, onto our render targets, okay? So let's add that in here. That sets our viewport and that sets our scissor rectangles. What we're going to need to do now, what we want to do next, is we want to be able to clear the screen so that we no longer see that horrible obnoxious pink, but we can now start getting a actual view of our render. So the first thing we need to do is we just need to clear screen. And if anyone is familiar with things like OpenGL, there's always a clear screen and it always comes with a color. Okay, DirectX has its own colors pack, but I didn't include that in, so let's just include that in here. DirectX colors, DirectX colors, there we go, which gives me access to this. And then I had this RTV. Now what this needs to be is this needs to be our descriptor handle. Okay, so this needs to be our handle for our RTV, but we're also going to use the current frame index and the size, and we're going to put that into, again, I can make this, but I'm just going to use auto. To be able to use that in, yeah, perfect. So this will now clear the screen. I'd love it if DirectX allowed me to just hit play now and show you, but unfortunately, until the entire program is finished, it's not going to work. Yeah, long and short of it, it's not going to work. If I try to run this now, it would just fail on us. Once we have cleared the render target, as in we have cleared everything on the screen and made the background black, we are going to want to clear our depth stencil. Basic as, clear the depth stencil before we make it. Again, we need one of these descriptor handles. So this one is a little bit easier. We don't need all of this information in here, so we can get away with just pretty much using this. So we're just going to say m equals that from there, and that works there. Next thing we need to do is we need to tell our renderer that we actually want to use these render targets and this depth stencil view. So we're going to do that by om set render targets. Okay, and again that will just tell the renderer that we want to use this render target and this depth stencil. I think the middle one is use multiple single handle to describe. Okay, not sure what the middle one is. I have on my code this one here muted out, but that is because later on I'm not going to need to call this. Once I invoke the UI, it will automatically change state of changing and transitioning to the present state. So later on I'm going to remove this, but for right now we need it. Now just like up here, again I said these are going to become easy. We have transition here from present to render, and here we're just going to swap back from render to present so that we can present what we've just done. Before we do anything further, we want to make sure again our command queue is empty. Command list is closed and execute everything on it. So we are going to close our command list and execute the commands. And then we are going to present, which means actually render to the screen. So theoretically, if I hit play now, it should work, but we just have one thing extra to do, which is we need to now we need to move on to the next frame and set the fence to ensure that we do not proceed until the GPU has completed what we needed to do. So we have our frame index, and our frame index is just +1. I could go ++. Ooh, I could do that. Frame ++. But what I want to say is frame index +1. But if I use this percentage, it's going to get the remainder of the value. And what that means is our frame index is currently 2. So our frame count is currently 2. If we go to frame index +1 and it suddenly gets to 5, for example, it's going to give it to us in the nearest value of frame count. So in that case, it would be 1 because we'd had multiples of 2, and 5 is a new 1. So in this case, it will give us to frame index 1. And then again, we're just going to flush the command queue, and that is going to wait for the fence so that the CPU can wait for the GPU to finish. And I believe, and I'm going to eat my hat if this actually works first time, I believe that is everything done for us to now have DirectX 12 working. And I'm actually a bit nervous to hit the play, so let's go for it. Let's hit play. Let's see what it says. Oh, I tell you what it's going to definitely do for us. First of all, it's going to give us L value errors. L value errors. Yeah, that's because we're not using L. Auto transition equals transition. We already have a variable called transition, so I'm just going to use it again. Put this one to transition. Let's have a go. So how long have we been streaming tonight? We must be on a good 2 hours and 16, it says here. Echoes of a dying star, and we have a black screen. And ladies and gentlemen, I meant ladies and gentlemen, well, probably lady and gentleman is more accurate. Ladies and gentlemen, believe it or not, that is DirectX 12. We maybe remember the last time we had a obnoxious pink window. And by adding this, we have now got a black window because we reset our render target to black. Now, there's quite a few things that I would actually like to do on this. I need to get it hooked up, so I might just do that quickly now. Hooked up so it actually resets correctly on the resize, but just for an example, we now have a green screen. And we now have, what other colors do we got? Blue. Voila, we now have a DirectX 12 window set up. Now, I know everyone is probably going to want to see objects being loaded in, and I mean, objects being loaded in is at least the 4th step along. But yeah, probably everyone wants to see those 3D graphics. But I do think it's going to be really important that we get that UI up and running and set first. And that is going to give us the ability to actually have a button on the screen that will allow us to say, go from one level, go to another level, go to another level, which will allow us to actually test our framework. As much as just building a renderer, we need to ensure that our framework is working and that our engine is strong. So, I mean, this is pretty much done. I'm going to put this back to black. You can just trust me that the black screen does indeed mean it's working. At some point, I'll replace that with a beautiful skybox. Black is working. Let's have a look at a few just small little changes, just to make our life a little bit nicer. Okay, function in window, I'm just going to call it show. show. Yeah, perfect. Let's grab that from there. Let's do another one, and let's just call it hide. Create that into existence. Just realised I can't hear anything at all anymore, which makes me think my headphones have died. Show hide. This one needs to be hide. Don't need to update the window when we're hiding. That just gives me the ability to come into render window now, and in here we can go show after we have reset the window, and therefore no longer see that pop-up of pink. Tiny little pop-up of pink. Maybe we could work on that, but either way it's correct there. Next thing I want to do is let's come into our window class here. We've got this here. Where is this? Message handler. Okay, let's have a look what we need in here. So in here I'm going to put a switch case. If it resizes, we're going to set MW width, which is our window width, which is what we've been using to get all of the information. It's in here. And we're going to set that from the low word and the high word, and we are going to run the resize function, which we don't actually have. So let's get that one as well. Void resize. There we go. But let's do that one, and then let's make that virtual so I can override it in the main class. Let's do virtual void resize override great. Let's just say if m underscore device. So if we've created our device, then let's reset our screen. Take that off of there and hit play. Audio's a little low. Is that just because I'm really tired and struggling to keep up after a 2.5 hour stream? Is this better, Wallabies? We have created a window, still got DirectX in, but if we do this, we are theoretically resetting our window. Let's put a little bit of a message in here. So, and I really should work at some point on getting this a little bit of a better reporting system or logging system, but I really wanted to just jump straight into DirectX12 because I know that's what everyone wanted. Render window reset. There we go. Right, okay, so there's a reason that's really important. The reason that is really important is because at some point we're going to be able to want to change what we can see on the screen. And if we didn't just go through and add all of that reset function right now, we would either end up with continuously bad graphics or just not being, or get multiple amounts of crashes, which is what I had trying to get everything working to get to this stage. That being said, I'm going to leave it there. I think what I'm going to do is I'm going to come back tomorrow night and we're going to carry on and add on the UI functionality. So for that, we're going to make an 11on12 interrupt layer. We are going to invoke DirectX 11. We're going to invoke Direct2D. we are going to add a few interrupt layers over this just to make sure that that works, and then we are going to start to build a UI layer. The next bit is a lot quicker than actually adding, getting DirectX 12 loaded in the first place, so it will probably be a shorter stream tomorrow. And then once that's done, we can start actually doing a few extra things in DirectX 12, which will be wonderful. But I think that's enough work for today. I think I'm happy with that. I think it's time to say goodbye. So yeah, I hope to see everyone tomorrow. It will be 8:30-ish GMT time, and I hope to see everyone there. I'll leave this on for a little while just to let everyone marvel at our new DirectX 12 window. But I wish everyone good night. Thank you. Goodbye. Oh, don't forget to like, comment, all of that. It really helps. You know the drill, but I'm a new streamer, so please do it. Thank you.